Hey everyone, and welcome to The Explainer. Today, we're opening up a really fascinating scientific investigation into a highly critical document, one that directly questions what's been called one of the most celebrated milestones in modern physics. We're going to unpack a major scientific claim and the equally massive critique leveled against it, keeping an impartial but intensely curious eye as we navigate this modern scientific debate.
And this brings us right to the central mystery posed by our source material. Is it actually possible that what the scientific community has been calling a monumental leap forward in quantum computing is really, well, just a beautifully disguised illusion? Today's explainer is really a journey into that gray area, where objective reality meets scientific perception, and we'll be exposing what the source claims are the hidden limits of modern quantum physics.
Okay, let's dive into this. The entire critique we're unpacking today centers its lens on one specific paper, published in the prestigious journal Nature back in February 2024. This was authored by a massive joint research team. We're talking Harvard, MIT, Caltech, and Quora Computing. Frankly, this is a paper that the mainstream academic world has absolutely been cheering about for the last year.
Now, to really grasp the debate here, you have to understand the massive gap in how this paper is perceived. On one side, you have the mainstream academic spin. The media and the scientific community aggressively praised this experiment. They called it a historical revolution, claiming it officially kicks off the era of error-free quantum computing. It was basically packaged as a definitive win to validate decades of theoretical funding. But when we look through the critical lens of our source material, we get a blisteringly different story. The source argues that if you actually look closely at the experimental data and the underlying mechanics, it is not a breakthrough at all. The critique claims it's literally just a pre-calculated show, a pure statistical illusion.
The big, flashy headline achievement of the Harvard and MIT researchers was this number right here, 48. They claimed they successfully created 48 logical qubits, which is supposed to be this huge milestone for error correction and stability. They used these 48 logical qubits to perform hundreds of quantum gate operations. But our source fiercely argues that this number is masking a fundamental, fatal flaw in how the machine actually operates.
Now, what's really interesting about how the source breaks this down is the methodology behind the researchers' GHZ state experiment. They break it down into three deeply controversial steps. The researchers wanted to prove their qubits could handle highly complex quantum entanglement, right? But the source outlines the actual process like this. First, they used a traditional supercomputer to calculate the exact mathematical probabilities and wave phases of the final answer. Second, they took those exact known parameters and forcefully injected them into the 48-qubit circuit using targeted laser pulses. And third, when the machine output the entanglement, they turned around and claimed the quantum computer organically solved the problem.
According to the critical analysis we're exploring, this means the quantum medium isn't acting as an independent brain at all. It's just physically mimicking the laser pulse inputs that were dictated by a regular traditional computer. The source argues pretty fiercely that an algorithm didn't organically calculate an answer to a mystery here. Instead, humans literally injected a pre-written answer scenario via lasers, and the quantum material simply reflected it back. It mirrors. It doesn't compute unknowns.
So if the machine is really just mirroring pre-calculated parameters, you might be wondering, how does the quantum computer actually arrive at the output the researchers publish in their paper? Like, how does it finalize the result? Well, this transitions us to the very core of the source's critique regarding the actual physical mechanics of the quantum output. The author of our source material uses a really great child-friendly analogy here to highlight what they see as a glaring contradiction. Imagine giving a calculator the problem 1 plus 1, but instead of just calculating 2, the machine essentially rolls a die endlessly. It spits out 5, 8, 12, 99 over and over again. Finally, on maybe the 1,000,000th try, it happens to roll a 2, and then the researchers point to that 2 and say, "Look, the calculator is a genius." The source points out the absolute absurdity of running a machine endlessly just to cherry-pick a pre-calculated, already known answer out of a mountain of total failures.
So the crucial point comes down to how we define the terminology used in the Nature paper itself. The researchers frequently threw around the words sampling and fidelity, but our source redefines these highly technical terms through a deeply skeptical lens. Sampling, in this context, actually means running the identical setup tens of thousands of times simply because the machine fails to output the calculation on the first try. And fidelity? That just marks the exact moment the chaotic output finally happens to align with the prediction the supercomputer already made.
The statistical breakdown reveals a massive contradiction. For the vast majority of the time the machine is running, it's just spitting out what the source literally calls garbage error values. It's only that tiny sliver of time where the random quantum output happens to overlap with the pre-calculated probability that the researchers declare a success and label it high fidelity. The critique emphasizes that this is a fundamental flaw, relying on tens of thousands of forced repetitions just to find a statistical overlap, rather than actually performing a true, distinct calculation.
To drive this point home, the critique makes a pretty striking comparison. It's like the concept of a rain dance. You dance continuously until it eventually rains, and then you turn around and claim the dance caused the rain. The source views quantum sampling exactly the same way. You run the machine continuously until it randomly matches the correct answer you already knew, and then you claim the machine calculated it. The critique views this entire methodology as fundamentally unscientific, arguing it's really just a brute force way of forcing a statistical intersection.
And this brilliantly illustrates what the source sees as a sheer physical contradiction in the experiment. On one hand, the output is incredibly meager, stabilizing just 48 logical qubits to verify basic probability arithmetic. But to achieve that tiny output, the input required is absolutely massive. We're talking hundreds of physical neutral atoms suspended in midair with laser traps, cooled to near absolute zero, and pumped with astronomical amounts of electrical energy.
The source summarizes this as a massive sunk cost problem. To get just a tiny bit of logical output, the researchers had to use hundreds of physical atoms acting almost as slaves just to stabilize the system. According to the critique, dedicating Harvard's massive, energy-intensive laser equipment simply to confirm a few bits of basic probability represents the ultimate negative efficiency. The sheer physical resources required drastically, almost comically, outweigh the logical output.
Let's move to how all of this builds into the source's overarching thesis regarding the limits of modern quantum physics. To quickly summarize the critique we've explored today, first, the system relies on pre-written answer sheets injected via lasers. Second, the supposed success is based on endless dice roll sampling rather than direct organic computation. Third, the whole process results in extreme energy waste for minimal output. And fourth, the resulting Nature paper, while wrapped in incredibly complex math, is fundamentally a beautifully disguised statistical illusion.
Which leaves us with this final, deeply provocative question directly derived from the critique. If the ultimate high-tech calculator, even one published in the world's most prestigious science journals, cannot autonomously calculate an unknown, but only reflects back the answers we already know after endless sampling, is the quantum revolution truly a historical breakthrough, or are we really just looking at a beautifully disguised illusion? It's a fascinating perspective for sure, and one that forces us to look much closer at how we define scientific success. Thanks so much for joining me on this explainer, where we always keep questioning the narrative behind the data.